Hello, this is Syed Moisesan and welcome to my video. Today I'm going to discuss my semester project, and that is line following robot. It is a project of my course microcontroller and embedded systems. If you guys has watched my previous videos, you would have known that I am a student of mechatronics engineering, currently enrolled in Air University Islamabad. So first of all, I would like to introduce you guys my group members who helped me in this project. They are Zuhaib Munir and Muhammad Ahsan. They are my friends and class fellows as well. Moving on to my supervisors, my most respected Sir Umar Farooq and Ma'am Sadia Said. They helped a lot in this project. They guided, mentored me during this project. They have mentored me a lot in this regard. So this is the actual picture of my project that I have submitted. If you guys notice, it looks quite heavy. Like I have included tons of sensors, like the ultrasonic sensor and the current voltage sensor and the IRs and each and everything. So unlike a conventional or traditional line following robot, it looks quite heavy due to the demands, or you may say the guidelines of my instructors. So it has been made according to them. So moving on to the discussion, here is the index of I created the index so to make it feasible for the reader to understand this report. It includes the proposal specifications, the components which we are going to discuss, block diagrams and each and everything, like the state machine and the flow diagram. And also I have included the Arduino code that I used, so that if any of you want to create this project or to reassemble it, you can get all the necessary stuff from here. I have included all the codes that I used, all the components that I used with their pricings as well, so it will be helpful for you guys to even budget this project. So let's discuss one by one. So first of all, we have the objective of this project. So it's simple, like I have made a line following robot. It has a IR sensor. It just need to follow a line where the line exists, and other necessary components like the sensors of ultrasonic sensors and the current voltage sensors. So moving on to our proposal that I had submitted, it states the same, that it's one of kind of autonomous robot which follows a line until that line exists. So let's say that the line moves on and it takes a right turn, then it takes a curve, and then it ends there. So the robot should be programmed like a way that it not only take turns and curves but also stops where the line ends, right? And if for example it faces any obstacle, so it should be programmed like that. It should take turn and then go straight and then move back to the line, or at least try to move back to the line. It was also nicknamed as Rehbar. So basically Rehbar is an Urdu term which means the guider, the one that follows the path. Yeah. So going to initial feasibility, I have divided this project into two parts. And for you guys, I also have a advice from my side that whenever you try to make a complex project, make sure to divide it in two parts, as it will be easy for you, or say convenient for you to ensemble it. Because while dealing with complex projects, you may encounter some great difficulties, like sometimes the components don't work, sometimes you made a mistake while assembling them. So in this regard, if you do step by step in this regard, if you divide the project in steps, like I divided into first level, that the robot was supposed to just follow a line in straight direction. There were no sensors, no obstacles, like thing, nothing. So its only task was to follow a straight line. When it successfully followed that line, I was confident that now I can put more sensors and craft it according to my needs. So step by step, if you build that project, it will be easy. And you can also assess your progress, like how much you have done. Like when it followed that straight line, I was confident that 50% of my work has been done. Now I just need to reprogram it and put all the components that are required. So step by step I completed this project. So like I used LCD and motor driver. I used 298 motor driver. It has basically two motors. In order to use them, I use this motor driver. So moving on to the specification, uh, these were being given by my instructors. So they asked me to design a custom Atmel controller based board. So I designed the PCB of this project also by myself, and with the help of my group fellows, of course. I used it on Proteus software. It's not that difficult. One who practice it can easily expertise in it. You can get tons of videos where they taught you how to create a PCB by following the schematics on Proteus. So the next thing was suitable structure bought from market. I used this structure with two motors, dual channel H bridge, right? And it was being asked to at least have a backup of 20 minutes in the back battery, like using a 200 mAh capacity. So I basically used 200 mAh capacity battery because this project was so heavy and it needed a lot of power to light up all the components. Even the Arduino was consuming a lot of power, and I had to recharge it several times in order to being able to showcase it. Next on, we have the SD card module to store the data in the SD card. There are IR sensor, ultrasonic sensor, color sensors, and then on embedded side we must use IO, ADC, timers, interrupts, and again Rapper. As I told you, its nickname is Rapper. So brain robot should send data wirelessly to a remote computer using wireless module. So all these specifications have been done in this project. So we will discuss it one by one, so it will be convenient for you to understand. So moving on to the team role. So one has done the report and software. Yeah, yeah, all the soft work was being done by Zuhaib. And then here comes Asan, who has done the code, right? And there's Moise. I did the checking, eliminating all the errors, or all the the part of the project that gives you a headache, I would say, like the eliminating the code with debugging, you may say debugging the code and then assembling the hardware. Sometimes the motor works, sometimes it doesn't, sometimes the Arduino works, sometimes it doesn't. Sometimes you have bought a component and it stops working suddenly. Then you figure out that it has been given more voltage than it was required. So there was a lot of trouble during making this project. It was a quite well learning experience, but yet difficult. It was a really a headache. So the checking and hardware part, I must say, was the most difficult, because it was my task to make this project run, right? I had all the necessary things. Now I had to just check it and make sure that it works. So if any difficulty I encountered, it was my responsibility to eliminate it. So the project was successful, but it took a lot of hard work and time. So the introduction. So basically this is a whole paragraph of introducing what a line follower is, and how it maintains its trajectory, what kind of sensors it uses, and each and everything which we have been discussing since the start of this video. One new thing which I need to tell you guys is that we used Arduino at Mega I used to 2598. So also has memory and more slots. So what are the features of this project? So as I told you guys that used 5 IR sensors. They gives you great precision, and it can also take turns on 90 and 45. So as I said that suppose we have some curves and turns, and sometimes the line ends or the robot is lost. So how is it supposed to get back? So it takes a 90-degree turns and 45-degree turns to find out where did it lost the line, right? So the project is capable to avoid any obstacles by using ultrasonic sensors. So what is an ultrasonic sensor? If you guys have any idea, then it's good. Otherwise we are going to discuss in the end of this video. Encoders are used to determine the speed of motors. We have used two motors for wheel mounted. Yeah, as I told you that that this was a two motor body, so it would help it to power it efficiently. We used the SD card ESP32 to create a data log and control the robot via Bluetooth and Wi-Fi connectivity. And finally, the project will also be displaying output as LCD panel. So what were the outputs? It was basically displaying what the current voltage supply is, what the current supply is, right, on the LCD panel. So it took a whole another level of programming in order to achieve this. So moving on to the operation, right? So IR LED photodiode called an optical sensor. This has been used, right? And steer robot requires steering mechanism for tracking. Two motor governing wheel motion are used for achieving this stuff. So like it doesn't have a steering. In order to turn its direction, the motor rotates in a way to turn its direction. Like one motor moves in forward direction, one moves in reverse direction, so it rotates accordingly. If the for instance the right motor moves in forward direction, for instance, and the left motor moves in reverse direction, so where is it supposed to turn? It should supposed to turn in the left direction. And similarly, if the left motor moves in forward direction and the right motor moves in reverse direction, so the robot will moves in take turns in the right direction. And similarly, if we want to take a 180-degree turn or 90-degree turn, so according to need, the robot can change its direction, right? So moving on to the components, as I told you, I may have mistakenly stated that I used any other Atmega, but here this is the correct number, Atmega 25. Right, so I was telling that the Atmega 2560 we have used it. So you guys can see that it has the chip and all the slots we need. And here's the input, here's the reset button, and here's the supply, each and everything we need. I also stated the pin configuration, so which component needs to be need to be plugged in here. All that stuff has been displayed here. You can guys review it. So here's the chip of ESP32. As I told you that it was being used for IoT. It's a kind of embedded system. It was the requirement of the project. Then we have the LCD. This is a liquid crystal display, right? And the SD card module for the storage purposes, and the motor driver. This is the motor driver LM298, right? So here's its pin configuration. Then we have the IR sensor, the ultrasonic, the encoder, right? And here's the ultrasonic sensor. So its working is quite simple. It uses magnetic rays. Those rays reflect back, and it tells us that if there is any object. It basically measures the distance between the obstacle by the speed of the rays. It reflects back. It gets back, right? So here's the motor I used. It was being connected with jumper wires, right? So coming to the soft part of this project, the software firmware design. So here's the complete the flow chart, how this works, how this operates. So here's the setups with the speed and the range and everything that needs to be followed. then it moves on that how is it is supposed to forward, or in what direction should it go. Here's the loop, and here's the each and everything, the all the format it the line following robot should or must follow, right? So we have the code here. So if anybody wants to create this project or reassemble this project, he or she can use this code. It's a custom code. You can optimize it, or modify it according to your needs. There are several sensors I used because it was the demand of the instructor again, but you may don't need that sensors, so you can eliminate that part of the code, so that your system can be optimized and don't need to run that part of the code. It is also available on my GitHub. I'll share the link in the description. You guys can go there and just copy paste that code and use it, or modify it as I told you. So here's the code. I don't think so if there's need to describe it. Here's the if else conditions and the digital write and each and everything, right? So moving on to the next part, yeah, that code just moves on. Here's the LCD part, the coding that requires to light up the LCD, and the sensors, yeah, everything. So here comes the simulation and final integration, and the compiled Arduino code. This is also available there, you guys can use it. The sensors, the serial ports, it uses the interrupts, that the timers and everything. If not the timers, at least it uses some kind of delays, so the the project can be optimized according to our needs, right? Here's the current voltage sensor and everything, and the read blue read value. This is the sensor of IR I was talking about, and the display, yeah, right. So it has been compiled, and compiled project. So yeah, here's the block diagram I was looking for. Yeah, so let me explain this diagram to you. So basically we have the battery that supplies this whole project. As I stated in the start of video, it was around 200 milliamp power, and the voltage regulator, it makes sure that the components get 5 volt. As the components are quite expensive, and they are sensitive as well to the voltage. If I supply them more or less, they may or may not work. So in order to eliminate this problem, I used a 5 volt regulator that makes sure that they get 5 volt supply. It is connected to the battery along with the sensors. Here the current sensor, here's the voltage sensor along with the buttons, right? And the IR sensor is connected along with. This is the this is the the AVR at Mega 2560, as I told you guys, and here is its pin configuration, the VC, the ground, and the 5 volt 3.3 volt it's of its own, and AN pins, AIT, D pins. So yes, these are the pins, and on the other side we have SPI pins for the SD card module, and for the ESP32, and for the LCD module, right? So also for the motor driver we have PW1, BW2. These were the requirements of the project, right? So this is the pin layout we must follow in order to the smooth working of this project. They are connected to the ESP32 and the SD card module. So basically here comes the supply to the AVR, the connection of the sensors to the AVR, and then the SD card module, ESP32, and here's the LCD that displays all this supply, that how much voltage we are getting or how much current we are getting. It displays that, and then it's connected to the motor driver and the encoder, right? The encoder basically connected to the D pins. So they are connected to the D pins, and the motor driver is connected to the PW1 pins, right? And the motor driver, if you guys watch carefully, the motor driver is basically connected to two supplies. One supply, the 12 volt, the main supply, it gets from the battery, right? Coming from the voltage sensor, and the 3 volt supply it gets from the AVR, the Atmega. It gets supply from chip 2, and it has been connected to the PW1 and PW2 pin, and then it has been grounded using the button. Button is connected to the current sensor, right? And then it is also connected to the encoder. The encoder is yet again connected to D pins, and the motor driver is basically then moves on to the motors and then the tires. Simple as that. And then we used two pins for the motors, and then grounded the two pins that are IN2 and IN4, right? So this is the simple block diagram of the this project. So it helps you to understand the basic working of this project, basic layout of this project. As in this picture you may not be able to do so, and in the above picture I told you guys that this is the picture of my project. It would be quite difficult for you to understand that which pins goes where, and what in what way it has been assembled. So the block diagram, the main purpose of basically block diagram is to simplify the project, simplify it, so that the person that is going to use it must not be confused, and it would be easy for him to, or her to again resemble it. It is a good practice. It is mainly used in engineering projects, so that the companies that work at larger scale, if they design a project or design a device or a product, I may say, those projects or products are meant to be used for years. So basically, if I am an engineer and I design that project or that product, and for instance I go out for like 2 or 3 years after the designing, then I must see this, that the designing I have made should be compatible with the other engineers too. I shouldn't design it in a way that they must call me back that what the hell have you made, and how are you supposed to to be able to. It should be understandable to other engineers. In simple words, if I made a project, it should be understandable by by other engineers too, so that they can continue it, modify it. This is the good practice I would suggest. So this block diagram would help you guys to reassemble it and remanufacture it again if needed. So this is the PCB I was talking about. This is being seems rough because the lack of equipment and other things. Nowadays people mostly make their PCBs through Chinese companies. They send their designs to them, and they make sure to fabricate it in a best possible way, in a best possible working way. So this has been made in a with the low quality, you may say, or lack of equipment, you may say. So basically the soldering, it looks good but not as perfect as you have seen in other devices. So it just like you can use it to just make things run, nothing else. So basically these are the pins and everything that are needed, and they are then again connected to the jumper wires. So this was the PCB, and this is soft form, the one I was talking about, made on Proteus. So basically we first make this, then we print it on a paper, then that paper is then ironed on that board that I told you guys, this board. Then we use a chemical FeCl free, pour some hot water in it, and then we put this board into that hot water, and then we all that unnecessary copper, we remove it, and then we use some kind of liquid, like you can use petrol, and then we remove the ink from the board, and here comes the copper we need, and it comes in this form, like this. So then we drill it, and then we put the components on it, then we solder it, and our PCB is basically ready. So this was the PCB, and these are the components I told you we will discuss in the later part of the video. Right, this is the ultrasonic sensor. So I was telling you guys that this sensor basically generate ultrasound energy, right? And ultrasonic energy sends a high pulse signal, then a low pulse signal in a continuous manner. Once these signals hit an obstacle, the signal reflects back and are received by ultrasonic sensor. The time taken by the signal to return is used to calculate the distance. So basically, the time basically is the measure that the signals come back in what time period, and that time period is then used to calculate the distance of the obstacle. Basically, the obstacle is being hit by that signals or that pulses, right? The project then sense how much it is closer to the obstacle, and how quick can it take the turns and avoid that obstacle. So then we have the IR sensor. I basically use LM393. It is a motor speeding measure sensor module. So basically, these IR sensors are basically used for the to follow the line, to differentiate between basically the IR sensor. The main work of IR sensor is to send infrared rays. It's basically used for the for path following. And then we have the motor driver to power our motors, and then being used to control them. Right, this was the motor driver I bought from market. Right, so moving on to the individual management. So one of my friend was to make sure that so basically this is the failure and success part, that what difficulties we encountered. So Mr. Zuhaib encountered that there were a lot of ways to approach it. In the end, after a lot of time, we managed to successfully operate the ILFR, but there were some setbacks approaching the end of time. We had some failure in ESP32 and SD cards. Yeah, of course, that SD card was not working according to our will. It took a lot of time, and Mr. Essen, who was basically designing the PCB and then fabricating it, it took a lot of money. One, because of burnt a lot of PCB, and some of them were defective. Of course, when you make the project, there are a lot of chances that you may end up burning the PCB or the component. And being a student, it's quite difficult to rearrange those components, especially when they are quite expensive. So in my part, this project took a lot of time because there were setbacks as PCB, mostly because the main problem is the soldering. I must say the fabrication is quite easy, but the soldering, I would suggest that it took a lot of time. Sometimes you not intentionally but unintentionally damage the PCB, and then it's of no use, and then you have to again work from zero. So it makes a lot of trouble for the one who is basically making the project. So here's the word count of this report. Mr. Zaib used 2000 words, SN used 650 words, and I 550. It is because the main task of Mr. Zaib was to write the report, and SN was involved in hardware work too. So he wrote 650, and my main work was the hardware and the checking of the project. So I only wrote 550 words. So basically, this was the conclusion of the project. The failures and its solutions are stated here, that how we managed to overcome them. And the feedback of the project was that it was an interesting project, I must say, a challenging project, I must say, and it took a lot of skill set, brainstorming, I would say, and in the end it have successfully being delivered. So I'm quite proud of myself and my group members also, that we have in the end managed to do so. And here's the final pictures you guys can see. This is the whole robot. It has one small wheel for the turning purposes, and these are the main motors. I used bigger tires. You guys can use small tires if you don't have that much load. You can see that it's triple story project, and here's the first floor, the second floor, and then the PCB makes the third floor. And here's the sensor and the IR sensors, the ultrasonic sensors, and those motor drivers and current voltages. And here in the right side you can see the AVR. So this is the front picture, right? Here's the display. The display I was talking about, that was showing the the voltage, how much voltage it's getting, how much ampere it's getting, and how much distance it's getting, what color of the line it's detecting. So this is it. This is from my side. If you have any query, if you have any problem, please do comment and let me know. I'll try my best to resolve it. And if you need any further information regarding this project, you guys can visit the GitHub profile and get your codes, get this code of this project. And this is it from my side. Thank you for watching this video, and take care. Goodbye.